In the second half of today's lesson, we will go ahead and solve some quadratics, again by graphing, but these are applied quadratics. So we get to see, why is it that we actually have to solve a quadratic equation? Well, here's an instance. When water is shot straight up out of a water soaker toy, the quadratic function is represented by this function here, y equals negative 16x squared plus 32x. Models the height in feet of a water droplet after x seconds. How long is the water droplet in the air? Well, let's see how the x-axis, as they said in the directions there in the problem, the x-axis is represented by the time, and the y-axis is represented by feet. And so what we can go ahead and do in this case is graph this by using that familiar formula of negative b over 2a. So what's the b term? Well, remember the equation goes this way, ax squared plus bx plus c. So in this case we don't have a c term. So typically when there's no c term, that means c is 0. And so what we're going to end up seeing is that it starts right there at the origin. The b term is the number out in front of x, so that's 32, so it's the opposite of 32. Over a, well, a is negative 16, so 2 times by negative 16. So we go ahead and do some work there. That makes 32 over 32, which just makes 1. Well, we're not done yet. We still want to find out how high this ends up going. We want to find the vertex. So the vertex is, when we substitute the x component of the vertex back into the equation, will give us our y value. So we have negative 16 times by 1 squared plus 32 times by 1. So you'll notice the same thing we had seen many times before. When we do these two parts, 1 squared makes 1 times by negative 16 makes negative 16. Here we have 32. So you see how these two are opposite in sign? One's double the other. So in this case, we end up with y at 16. So if we go over 1 second, remember this is our axis of symmetry. This is where, after this 1 second, the water droplet has made it to its highest point, and then it will start its decline back to the ground. And so we go up 16 spaces, and that's our point. Well, that means that we have the axis of symmetry right here. If we use symmetry, we can find out where the other point that's opposite of this is, and that is at 2 seconds. So what that tells me is the graph's going to end up looking something like this. It's going to come down to this point. So really it's starting up here, it's going up, and it hits that top spot at 16 feet, and then it comes back down. And when will it hit the ground? I believe that's what they're asking. How long, so that's time, is the water droplet in the air? Well, it's in the air all the way from 0 seconds until it hits the ground at 2 seconds. So you would say 2 seconds in air. So that's what we're doing on these. Now notice that once, for this problem, when it starts on the ground, it's only if it starts on the ground. If it started up off the ground, it would be different. But when it starts on the ground, once you find that axis of symmetry, that means it's just double that value, because from that initial point to the axis of symmetry is that 1 unit, and then it's that same distance to where it hits the ground. Well, we see the same situation in this one where Gretchen throws a ball straight up into the air. The quadratic function y equals negative 16x squared plus 48x models the height in feet of the ball after x seconds. So this is our x-axis, this is our y-axis. And use the graphing calculator to sketch the graph of this function. Well, I don't have a graphing calculator. Graphing calculator is my hand, so we got to figure it out here. Use zeros to find out how long the ball is in the air for. Well, zeros are where it crosses the x-axis. So that's what this term represents. This is the same thing. There's a couple other ways we can represent this. They can say solutions. They could say zeros. They could say roots. They could say x-intercepts. And x-intercepts really describes it well, because that's what they are. So let's go ahead and do this job here. We're going to use that x equals negative b over 2a. Substitute our numbers in there. Remember, 48 is the b term, so it's the opposite of 48 over 2 times a, which is negative 16. So we do that work, we end up with a negative 48 over negative 32. So we can reduce this fraction. The negative signs will cancel, but also see some numbers that go in here. Actually, 16 goes into each of these numbers, and that ends up giving me 3 over 2. Now, this would be 1.5. Now, 1.5 helps describe it, but 3/2 is what I'm going to end up using when I try to find out how high this ball ends up going. And this ball ends up, well, we'll figure that out in just a minute, but we have 1.5 seconds. So here's the 1.5 seconds line. It's our axis of symmetry. And really, since this ball starts on the ground, I know it starts on the ground because it doesn't have a c term. The c term is what we would have when we set x equal to 0. Well, when we set x equal to 0, there's nothing left. So no number, so y is 0. So really, just by looking at this graph, I know the highest point is going to be somewhere up in here. That means that if I go over 1.5 seconds, I'll be to the maximum height. 1.5 seconds from then, I'll be back on the ground. So really, the answer is going to end up being 3 seconds. How long was the ball in the air for? 3 seconds in the air. So I could find out the answer a little quicker, but I'm going to go ahead and try to find out how high this goes because I'm interested in that. So if I wanted to find the maximum height, I would do this. I would say y equals, and then I would go ahead and substitute the 1.5 in. But I'm not going to use 1.5, I'm going to use 3/2. So it's negative 16 times by 3/2 squared, and then plus 48 times by 3/2. So 48 over 1 times by 3/2. So watch the cross-canceling that goes on as we do this problem. Negative 16 over 1 times by 9/4 plus, and then here 2 goes into 48 24 times. 24 times by 3 gives me 72. Over here, 4 goes into 16 4 times. Negative 4 and 9 makes negative 36. And as I said before, when we're trying to find that vertex, these two numbers are going to be opposite and sine one double the other. So y equals 36. So it's 36 feet. This is the maximum height. And so if I go up 36 feet, that's about right about here. And then I have an understanding about what that graph looks like. So it goes down until it hits that point. Here it goes down this way until it hits that point. So that's a good representation of the graph just using those 3 points, knowing that it makes a U-shaped graph. So I know a bunch of information. 36 feet is the maximum height, 3 seconds in the air, and it only takes 1.5 seconds to reach the maximum height. And on a test in the future, you're going to end up seeing this, where you're going to be asked for these 3 bits of information. That's all you have to do is find the vertex, and then from there use symmetry to find the last bit. Well, those are some of the problems you'll see on tonight's homework. Good luck.